Hello everyone, welcome to another episode of CNCA KCNA Bootcamp by CNCA Gandhinagar. And we had covered most of the things around Kubernetes, cloud native architecture, but the thing which was remaining is cloud native observability. As nowadays many people are using observability, and observability is helping a lot of companies to grow their application and monitor their application. So we have an expert Naman Vyas, who is working as a software engineer at middleware, and he has an immense experience on observability. So let's welcome him. And Naman, the stage is yours.
All right, hello guys. I'm glad. Thankful for the CNCF Foundation and shout out to Neil Shah for arranging this stream. So we will start with today's session on cloud native observability and open telemetry. So share my screen. Please acknowledge when you can see it.
Yeah, it's visible.
Okay. So first of all, it's the as Neil Bhai said, it's fourth week of the CNCA bootcamp, and we will be discussing observability. So this session would serve as a primer for you guys, an observability 101 primer. At the end of the session we will touch upon and also have a technical understanding as well as conceptual understanding of observability principles and the three pillars of observability, the history of observability, and current scene. So let's start. All right. So quickly, can I have a show of guys in the chat? Uh, how many of you are developers, and how many of you are like DevOps guys? And again, this will not, this will not be a session, all right? This would be mostly a discussion. So imagine we are sitting around in a circle and talking about observability.
Yeah, feel free to drop your message over here.
Yeah, you can drop the message um, or straight up speak. So okay, we'll move further, no worries. So three things we will be discussing is few things we will be discussing here in our session is what is observability, what are the three pillars of observability versus monitoring, tools and some best practices. And also we will have, which is not part of this PPT of course, but we will also learn something about open telemetry as well. So
And Naman, can you please share the whole PPT? It's like the PPT and the slides down.
Uh, Sure. So, how would I manage that? Let me download it and share you as a link. Or
It's in Canva.
yes, it's in Canva. I can share you as well.
Yeah, you can share your full screen. So
All right.
it will be there. You can share the full screen, and it
All
will
right.
be fine.
Uh, okay, just let me stop this right here.
Yeah, you can share the whole full screen. So it will be-
Entire screen, screen one. Let's go. And we have. Sorry.
Being a developer, you do that.
Yeah. All right.
Yeah, fine, perfect, perfect.
Okay, so let's start with observability. So first of all, we already discussed what we will be discussing in this session. So let's jump straight into what is observability. So it is a mouthful actually. The definition of observability is mouthful. It is defined as the ability to understand a system's internal state by analyzing outputs in dynamic distributed environments. Now, this may seem like a lot. So, for example, and this definition is the standard definition you find on the web, but this definition actually, I believe, does not carry all the context of observable systems. So if we think, what, what is an output of of a modern app? Let's say if we are talking about Amazon or uh, any other e-commerce giant, what is an output of Amazon's app? So for example, if I go around, let's say this is my again my screen is visible, right? So uh, if we go around to a website, let's say this is Mackey's website, all right. So this is itself an app, right? But what's the output of this map? Here in the here in the uh, in the can in the definition, we can see by analyzing outputs. So how would we understand the overall architecture or even what's going wrong by just looking at the final product? So is the output the web page it is, it's rendering, or is the output the values in the database for the current inventory? What can be the output? So, and how do we analyze this? That is the question here. So when we say by analyzing outputs, we are not literally meaning the outputs, but we are thinking about telemetry. Now, observability is only possible if a system or an application is properly instrumented. Now, what is an instrumented app mean? So instrumented an app is called, or a system itself is called instrumented if it produces data slash telemetry that gives an outsider entity an understanding, a view inside of the working of that application. So for example, uh, observability, a system will be observable if it is producing data, uh, like how much data like how much uh, metrics, or what is the latency of my each http requests, or how what is the speed of rewrites in the database, how many pages are being rewritten, or it can be output like uh, what is the time of a user that is on the website. So if it generates this kind of data, and the data is of a kind that we can understand the inner workings of the system, then the ability to analyze that data, analyzing that output, and understanding the internal state is called observability. So previously, the shift that happened after observable systems came into picture was, we were asking, is this system up, is the website running? But now we can ask for an instrumented app, we can ask, why is this system behaving this certain way, even if it is good, even if it is bad? So what is this telemetry, and what actually is this data that an instrumented app outputs for it to be observable? We will understand that in this talk. So am I clear on the definition of observability in instrumented systems? Again,
Yeah,
अगर
yeah,
एग्जाम्पल
it's clear mostly.
हाँ, अगर एग्जाम्पल से समझना हो, तो ट्रेडिशनल मॉनिटरिंग ये है कि हमारे पास एक कार है, और वो कार का डैशबोर्ड हमारा ट्रेडिशनल मॉनिटरिंग टूल है। पर कार में अगर चेक इंजन लाइट ऑन है, तो फास्ट एंड फ्यूरियस वाला वो जो मैकेनिक है, वो जैसे अपना लैपटॉप कनेक्ट करके सारे सिस्टम्स देख पाता है, दैट इज ऑब्जर्वेबिलिटी। सो it I guess it will be more clear, uh, more clear when we start discussing the data, and in particular what is the data, or what is the telemetry data that an observable system outputs. But also, let's say why it is needed, why observability matters. So previously we used to the IT scene or the computer engineering scene used to rely on very closely knit, tightly coupled monolithic systems. All right. So the problem was, uh, if let's say I have a monolith and I'm 20 years back, and I have my database, my backend app, and mostly everything in a single EC2 container, EC2, or a single virtual machine, then if my product is not working properly, what I would do is I would SSH into the server. I would start viewing the system logs in the var/log directory, or I will straight away type htop to see the to see my CPU metrics. But in this era, we have many different challenges. Again, in the cloud native context, we have a series of challenges. First challenge being ephemeral containers. Ephemeral can be a weird word, but a Gujarati or Hindi for it would be like kshan bhangur. So we have containers who we don't have any idea how much reliably this container would be running. So the idea of SSHing into a container would be difficult, because where would I know to look for logs, right? Another problem would be, another challenge would be service dependencies, because now we are moving in the microservice world. Like, we can have apps that has, for example, your MySQL database is in a Kubernetes container, let's say Kubernetes cluster. Now it is separated from the backend API that is in another KTS cluster that is managed by another cloud provider. And somewhere along the line, some developer comes and uh, he makes a microservice that is the dependency of the backend app, and he is hosting that on a simple virtual machine, right? So the problem becomes, where would I look at? I would be blind. I would be looking for a needle in a haystack, so to speak. So these are the challenges why we will need observability when it comes to cloud native environments or deployments. So also there is a, imagine if find even if there are hundreds of services, 100 plus microservices, imagine the time taken to find out which service is causing the problem and then fixing the problem. So the mean time to resolution will be really slow. And plus, until the point where we will be finding the problem, we would have our service would be either down, or we have to spin up another instance and serve another system instance of that monolith, and serve that monolith, and then we will be debugging in a isolated environment. So these are the challenges why uh, we will need and why observability is a burning need for many companies. So how do we solve this problem? We How does observability come in and solve these problems? It solves this problem with the three pillars of observability. These three pillars are metrics, traces, and logs. All right. So first we have metrics. When I say metrics, traces, and logs, these exactly is the telemetry that the system will be producing, the instrumented system will be producing. And by looking at this telemetry, this data divided into metrics, traces, and logs, we will be able to exactly pinpoint, or it would be more easier for us to pinpoint where the problem is lying. So let's dive into each of these three uh, pillars. Let's start first with matrix. All right. So the definition of matrix goes like this: time series numerical data. So time se- a metric, a singular metric will have a numerical value associated to a property or a behavior of system at that particular point of time, and it is time series value. So the time is a component, uh, s- such that you have a context of what was the metrics a few time ago and what is the metric now. So the historical data here is of importance. There are many tools for viewing metrics or for uh, instrumenting your application with metrics, for metrics, and these are like Prometheus, Grafana, Datadog. Prometheus is for exporting metrics. Grafana is, again, these two are open source. Grafana is for creating dashboards and beautiful visualization. This is a Grafana screenshot. And uh, and there are observability vendors like Datadog who also have support for metrics. The best practices of metrics here goes like, use high cardinality metrics sparingly. Now, what does high cardinality means? Cardinality means the amount of metrics, if the matrix is generated, like, let's say, every millisecond, or the amount of metrics is very large, then please try to reduce or be skeptical of using those metrics. But let us have like a practical or example of what can constitute a metric. So I will hop on to my uh, Excalibur tab. All right. So let's say that we have a backend API. All right, a backend server which is hosting many APIs. Right. So one metric could be uh, one metric could be, let's say, HTTP requests per second. Now, this would constitute as a rate metric. So, on this server, for every second, how many HTTP requests are coming? So, how would this prove valuable uh, for a guy like us, for a developer like us? Sorry. So let's think this is the graph, and here the y-axis shows the HTTP request per second, HTTP HTTP requests per second, and again the metrics are time series values. So uh, the x-axis will obviously be, you guessed it right, time or timestamp. Now, generally, if you see your traffic generally goes like, let's say this is 100 requests per second, and your traffic goes like, fluctuates like this. All right. But if you see a spike in this traffic, you know that the users have increased, or the platform needs to scale right away. So that can be, and the users have increased. Now you can correlate this event with this particular timestamp to, let's say, to another metric, which can be CPU load. So if at, at this time period the CPU load is exceeding, let's say, 90%, then you have an actionable insight that, oh my god, Anna Diarmas has gone live on Instagram, we need to scale up those clusters. So this is how you can have an insight. Let's take another example. All right. Another metric which is used fairly frequently is the HTTP error rates or HTTP response rates. So we can create a few metrics here. Let's say phi xx dot h phi xx response rate, or we can have 2xx dot response rate, 4xs responses rate. Again, when I say rate, it can be per second or per minute. So for, let's say, for if I'm seeing the 5xx response rate to go from, let's say, values like this to a spike, we definitely have an actionable insight that some code inside my server is probably causing problems. So now I can have I can go and uh, log into my SSH, or see the logs of my HTTP server and filter using this 500 response. So I will exactly know what problems are being caused. Or if it is 2xx response rate and it's going down, you can say that, all right, my users are not exactly getting the required response. So this is an example of metrics. This is how exactly metrics load up. uh, Now there are few types of metrics, we can discuss it. So there are, actually, in observability there are three types of metrics. First one is a counter metrics. It tracks the cumulative occurrences. अगर एग्जांपल से समझना हो, तो if you ride a bike or an Activa or even a car, let's say, the car has an odometer, right, which tracks how many kilometers since you have bought this vehicle you have ridden or driven. So that will always be going in a single direction, that is increasing, by means that the kilometers in the odometer will always be going upwards. Or uh, and in our context, in developers context, how many total requests have been made against our HTTP server. So this would be a counter. Now, can you give me like an example for monotonically decreasing uh, counter? It can be it can be uh, in the context of software engineering, or if you like me, in the context of motorcycling. So, do we have any examples? I can give you one more example of monotonically decreasing metrics. That would be your fuel gauge. Your fuel gauge will be monotonically decreasing, or 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 like my bank account, it would be monotonically decreasing till I get my salary the next month. So that is the example, and that is the example for a counter metric. Now, second type of metric is a gauge matrix. Now, what is a gauge matrix? It is a snapshot of a value at a particular time that can increase or decrease. Again, if we are thinking about the context of motorcycling again, this type of metric would be your speed, or your RPM. So RPM at a given point of time can be increasing or decreasing. But it's if my RPM is continuously increasing, that then I can know that there is some problem with my engine, because it is not, or my throttle, because the RPM is not coming down. So that can be a gauge metric. Examples in computer science world would be the current RAM usage. As I said here, if the users are low, if there is not a huge load on your server, currently your app would be idling, your RAM would be at a few 1 or 2 GBs. But if there is a herd of users, it will scale to, let's say, 10 or many more GBs, right? So that is a gauge matrix. Another gauge matrix example would be active connections, the number of database connections that are open. So, for example, it can be if there are many requests, or if we are scaling our backend services and creating more connections for it, then this database connections would be increasing, right? So that's gauge matrix. And last and probably a very interesting type of metric is histogram. All right. So uh, and a real world example of histogram would be जब हम स्कूल में थे, ऑल राइट, और स्कूल में टीचर वो स्कूल में बोर्ड लगाते थे. अगेन राइट नाउ the competition is great, so we don't see these kind of boards. But back then actually many significant people were failing in schools. So people used to say that 100% result lay now, so we will get 100% results in our school. That means that uh, all of the students are passing. But if you that gives you 100% result for the school, right? But if you look into it, look into the details, the top student is hanging around at 65 percentage. So this really cause a problem for an observer, right? You will, if you are a parent and you want to admit your child into that school, you will first the 100% result metric is not useful for you. You need a histogram metric. Now, what is a histogram metric? It says it measures across a value distribution. So, for example, a histogram metric will say that for 30% or 35% students had the marks between 35 percentage to 45 percentage, and 50, and very low or P99. I mean, P99 means percentile 99. That means very small amount of people even had the very small amount of people were passing with really good grades. So in context of our observability or our computer science uh, environment, example can be HTTP request duration seconds. Now, if we take an average of HTTP duration of all the requests, the average might say 40 millisecond, and that average can be misleading, because for, let's say, for 10% of your users, the latency would be around 10 seconds or even 3 to 4 seconds. So the P, if it is only 10%, then the percentile 90 or P90 latency would be 4 second. But the misleading average was 40 millisecond. So using histogram metrics can save us from the lie of the average. All right. Another example would be the order amount USD. So 70 percentages of, let's say that the average is around 150. All right. But only the 30% of the purchases were exceedingly expensive, and 70% of the orders were even less than 100. So that is changing the averages, right? So a histogram metric can save you in that case. Now let's move to the second pillar of observability. Second pillar of observability are logs. Now, logs are timestamped records of discrete events that has happened in our system. Okay. For example, the like, metrics can tell you how many of things have happened or how much of things have happened, but logs have the ability to tell you that what exactly happened and when it did happen. So uh, the purpose of logs can be debugging, auditing, security analysis, etc. So logs typically include, and again, you if you have programmed for a while, you definitely know what logs are, right? Even the console log, or for in my days printf itself, that is also a log. Because when we used to be debugging, when we used to write printf, we exactly know that when the execution has reached to this particular point, an event has occurred. We can have levels into our logs. Levels can be errors, debug, info, etc. So a debug would be for development. So for example, we can start our application in debug mode to generate more logs and see exactly, have a detailed picture of what is happening inside the application. And while we are pushing it to the production, we can have only the info logs, and of course the error logs. Now, a key practice is a practice when we are discussing logs in terms of open telemetry or other observable systems is, a good practice is to have the logs in uh, as structured logs. Now, what does structure log means? It basically means that logs will follow a specific structure. So we can have things like timestamp, then we can have things like CVR, okay, spell check, CVRET level. We can have the component or the service slash component that is causing this log, or that is the component to which this log belongs, and then we can have the message. So this structure makes the log easily queryable, and we can have more information from these logs if we provide a log structure. Another thing, key practice or best practices for logs, or general practice for logs, is don't log sensitive data. Again, this would be a very obvious thing not to do, but you will be surprised to know that how many like breaches or happen, or how, like, again, we are going a bit off topic here, but there is a huge amount of data on breach forums. Breach forums is a website where people post data breaches on the lesser known part of the internet we don't want to discuss here. But yeah, many, like, you will be surprised to know the amount of data leaks that happen due to just with people not avoiding sensitive data in the logs. So another thing is, one very important thing also, that logs are easy to generate but are easiest to over generate. So for that, the observability providers try to have these two things, uh, that is automated archiving slash deletion. So for example, like, it is not uncommon to see clients for me, that see customers that generate more than 50 or even 100 GB logs per day. So for a retention period of time, we can retain that in our database, through which we can query, and through which our customer can query. But after a certain retention period, we definitely should archive them into a cold storage or straight away delete them. All right. So, and third pillar of observability is tracing. Now, what this can be somewhat tricky to understand. Traces. So what exactly are traces? Traces are the records of a request's path through the distributed service. Again, if we move back to our example where different things were hosted on different platforms, the database service was hosted on another cluster, the backend service was hosted on another cluster, or on another VM, the authentication is hosted on another VM, and you see the basic pattern of distributed computing, right? Not distributed, but distributed systems and distributed services. So traces, what traces allow to do, they track the journey of a request from one service to another, and the whole flow of service. So with this, uh, how do they do it, how do trace do it? We have spans. So span represent a single operation. So let's say if we can zoom in on this, let's say that this whole diagram is a trace, but the individual lines are spans. So for when the request starts, let's say the blue one is the backend client. Now the backend API endpoint. Now once, let me go with an example on Excalibur only, that would be more helpful. So let's say that you create a post. Have a post method on slash orders, uh, with just, let's say, order ID. You order some item, right? Now, just on the first go, it will hit the endpoint, right? So it will hit the backend endpoint. Now, the backend endpoint will first try to authenticate. Now, there would be an authentication service running, right? So it will be serving further, and then after authentication completes, you start the inventory call. So with traces, you get the idea. With traces, uh, you can actually trace the whole journey of a request, and these individuals are called spans. And how do we correlate between them? So each span would have a parent ID and a child and child ID, which can be array because it can have multiple child, right? So this is how you can see traces. So traces will be helpful in finding out at which exact service my request is breaking, or which service is exactly the problematic service, the problematic code for my whole request. All right. So yeah, here we go. So that was it. Now here we complete our uh, the observability part of the talk. Now we'll talk a bit about the open telemetry part. So uh, what is like the current scenario of what is the current scene of observability world? We have a project called open telemetry, and if you are into CNCF, then open telemetry currently is the second most starred uh, project on GitHub for CNCF, just after Kubernetes. So that alone can say how important this project is. So uh, before understanding why OpenTelemetry is uh, really important, and how it has changed the landscape, a bit of history can help, right? So previously, before OpenTelemetry, we used to have uh, different libraries for different whole different frameworks and different tools for different signals. So for metrics, we had like Prometheus, StatsD, or vendor specific solutions. For logging, we used to have language specific frameworks, like for log4j for Java, Zap for Go, etc. And for tracing, you had to choose between open tracing, open consensus, Zipking, etc. Or Jaeger was also a big thing, and it's still a big thing. But there used to be problems. So the first problem was inconsistent developer experience. So uh, imagine, all right, you uh, open telemetry does not exist, and you go to an observability vendor A. Let's call it data cat. All right. Now, your observability vendor DataCat uh, asks you that what is your tech stack, what is your deployment stack. So you would say that I deploy on K8s. For database, I have let's say MySQL. For backend, I have Golang. All right. So and you create dash and for all these three things, or and for uh, for more, DataCat has met many metrics, right? It provides you metrics to observe this. So let's say from our previous example, you have with previous example of an important metrics, we have HTTP slash requests slash requests per sec, right? Per sec. Now, if you are moving from another if you are moving from another vendor, the metric exactly wouldn't be, it is not sure that the metric exactly would be named like this. It could be uh, HTTP rec per sec. So this is just one kind of inconsistency. But imagine now, you for if you have a separate in-house dashboarding solution, you have to rewrite everything. So the across and also for every observability solution, they call they also have different conventions. So for example, they might call counter they might call let's say rate metrics into something another. So the namings, the convention is not exactly same, which led to inconsistent developer experience. Another big thing would be vendor lock-in. So for example, now let's say that your tech stack grows to uh, dot. Let's say you have more than 30 types of integrations that you want to observe in your tech stack, and for each and every 30 of them, you have created dashboards, and you have created uh, dashboards that also represent the communication between all of these, and you are quite happy with your observability setup. Now someday DataCat comes and tells you that from tomorrow, I our rates are going high, uh, and let's say your previous infra cost was around 100K. Now it is crossing 200 to 300K. And again, it is it is very common in observability vendors, in big observability vendors, that the cost of managing your infra is sometimes even less than cost of observing your infra. So naturally, things don't go well financially, and you want to switch, or you find another deal breaker and you want to switch. Now there is no way, there used to be no standardized way to ship all those dashboards that you had in DataCat to another observability vendor. So if I were to switch, I had to write I had to create the dashboards from scratch again, or I had to hire in some really good programmers who can transform from one format of an observability vendor to another format. But this was a headache. So yes, this was present before OpenTelemetry was present. Now when OpenTelemetry came in, what it defined is standard. Now what exactly is standard? OpenTelemetry said that actually, if you see, OpenTelemetry itself is more than just a program or a set of program or a framework. It is a specification. So what open telemetry does is specify that for, let's say, MySQL, for let's say HTTP request, please name all every or it tells to every observability vendor that standard name for this particular metric is exactly this. So if you follow this kind of convention or a specific convention, then there would be no vendor lock-in, or uh, it would be easy to switch from one vendor to another. Also, it would make your observability stack vendor agnostic. So this was the key thing, and according to me, the key feature that OpenTelemetry got. And it was that there was now a consensus between in the observability world. OpenTelemetry also has a very interesting, if you see the code, and if you see the source code of OpenTelemetry, and if you dive into discussions, they have very strong commitment for backward compatibility. So they they have a seriously strong commitment to avoid breaking changes. So that was OpenTelemetry. uh, Again, and that actually brings this session to an end. Now, if again, we were limited by this session, so if time permits, we can also have sessions where we can set up telemetry, but that's for another time, or for another lecture.
Yeah, yeah, true now, true. So it was very insightful session and like a lot of things around observability space we discussed. And hopefully we can also have a hands-on workshop on setting up the open telemetry sometime after the KCNA bootcamp.
Yeah, so after this bootcamp finishes, we can have like kind of a live coding stream, or let's say a group session where we can have let's say we can make a simple app, and then try to monitor it using open source tools. So we will use open telemetry as a consensus, as a specification, and then we will use, let's say, Prometheus for metrics, and other things for logs and traces, and then we will have nice beautiful dashboards on Grafana.
Yeah, true, true. So if someone have any question around observability, like what are the key concepts of observability or something, you can put your questions over here. You can also ask over here.
Again, if you are feeling shy, I'll drop my email, or even we can connect on, if this feels too much official, we can have Discord sessions as well. So yeah, if you have any questions, you
Yeah,
can.
you can drop your email or LinkedIn over in chat so we
Middleware.
can connect.
uh, that's my email, and that's my LinkedIn, and this is my will be definitely we will also be sharing the materials and the notes I have made for this session, so it can be helpful in your exams. So once it is formatted correctly, I guess I will share it to Neil, and then Neil can forward the notes to you. uh,
Yeah, I will share all the things in our WhatsApp group. And yeah, that's it for this session, I guess.
all
Thank
right.
you. Thank you all for joining, and thank you so much, Naman, for coming over here and sharing your insights on Outdoor Space. Thank you. Thank you, everyone, and hope to see you in the last session of the KCNA Bootcamp next Saturday. Still then, you can learn a lot of things around observability to clear your concepts around CloudNative observability. And yeah, see you in the next sessions. Thank you.
Bye, bye, guys. Bye,
Bye.
Neil. It was great.
Thank you.